Hey, I'm Mitchell. Welcome to another video in the RSP education series. Whether you're powering up a motor, an HVAC system, or a rooftop solar array, choosing the wrong disconnect switch can cost you big time. From voltage mismatches to arc flash hazards, the risks are real. But don't worry, this video is going to give you everything you need to size and select the right disconnect switch like a pro. We're breaking it down, starting with load types, voltage and current ratings, environmental considerations to think of when selecting and sizing disconnects, pulls and throws, and more. Stick with us through to the end because one wrong assumption could burn your budget or your equipment. If you like this kind of content and want more educational videos, please like and subscribe. Also, this video is for educational purposes only. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's get right into it. So let's start with how to size and select a disconnect switch. You want to start with load type. We're talking whether it's motor or HVAC or solar or lighting, etc. Different types of loads require different kinds of switches. Motors, HVAC systems, solar panels, lights, they all pull power in their own different way. Motors usually have a big surge of current when they start up. PV or photovoltaic solar systems, these setups run on DC power, not AC, so they behave differently. Lights might have extra parts like ballasts or drivers that change how they operate too. Motors need disconnect switches rated for horsepower. Specifically, if you're dealing with a motor, make sure to get a disconnect switch that's rated for its horsepower. This isn't just a suggestion, it's what keeps the switch from getting fried by the arc that happens when you shut off an inductive load like a motor. With HVAC systems, they use a mix of loads together. They're a bit more of a combo. They use both motors and compressors. So when you're picking a disconnect switch, look at the whole picture. Total load, types of components, and how everything works together. These systems often need multi-pole disconnects and weatherproof housings. Solar or photovoltaic setups, they need special DC rated switches. For solar panels, the disconnect has to be able to cut off direct current, which is a lot trickier than AC. DC arcs are tougher to stop and need specially designed switches that can safely handle high voltage and possibly high fault currents. Lighting loads might look simple but still have quirks. Lights, especially LEDs or fluorescents, they often seem like simple resistive loads, but not always, because if they have ballasts or drivers, they can cause inrush currents or generate harmonics. Make sure the disconnect is built to handle all of these kinds of switching conditions. So when you're sizing and selecting a disconnect switch, you need to consider voltage and current ratings primarily. Make sure the voltage matches your system, whether it's AC or DC. When you're choosing a disconnect, it's key that its voltage rating meets or beats your system's voltage. Whether that's 120 volt or 240 volt or 480 volt, make sure it's a match. And remember, AC and DC ratings aren't the same. A switch rated for one doesn't automatically work for the other. A current rating should cover the load amps plus a little more. Check the full load amps or the FLA of your system and pick a disconnect that's rated a bit higher. Most people give it about 10 to 25% cushion. If you're working with motors, use the FLA from the nameplate or NEC chart to guide your choice. Don't skip over short circuit current ratings or SCCR. If your disconnect switch isn't backed up by a breaker or fuse system that protects it, it needs to be able to stand up to the worst case fault current by itself. This is a short circuit current rating. Really important for keeping things safe when things go wrong. Things to keep in mind around environmental conditions, like whether you're indoor or outdoor or around hazardous areas. Indoor versus outdoor, that changes the box you need. If your switch is going inside a building, a NEMA 1 or 12 enclosure might just work fine. But if it's going to be outside, go with NEMA 3R, NEMA 4, or even 4X. In corrosive places like near salt water or certain chemicals, go with stainless steel or fiberglass for extra protection. Think about water, dust, and chemical exposure. If the switch is going in a place where it might get sprayed down or exposed to nasty chemicals, like in food plants or factories, make sure it's rated at least IP66 or NEMA 4X. These ratings mean it'll stand up to water jets and chemical splashes. Let's talk explosive environments. You're going to need to use rated switches only. So if the area has explosive gases or dust in the air, like in oil refineries or grain facilities, you need a disconnect that's approved for hazardous locations. Look for Class 1 or Class 2, Division 1 or Division 2 ratings per NEC and UL guidelines. These switches are built to handle those kinds of dangers. So let's talk about now number of poles and throw configurations. First off, what is a pole? Think of a pole as a pathway for electricity. Each pole is connected to one live conductor, and a conductor is a wire that's carrying live current. When we say a disconnect switch is 2-pole or 3-pole, we're saying that the switch is built to interrupt or connect 2 or 3 separate electrical lines at the same time. So what's a conductor then? In simple terms, a conductor is a wire that carries electrical current. There's different types of conductors. You have line or hot or live. So line or live, this carries voltage from your power source like L1 or L2 or L3. Neutral carries current back to the source to complete the circuit. And then you have your ground. That's going to provide a safety path in case of a fault. Doesn't normally carry current. Poles are designed for switching the line or the live conductors and sometimes the neutral too, depending on your system. So a quick recap. Motors, go horsepower rated. HVAC systems, consider the full mix of components. Solar, DC rated or nothing. Lighting, ballasts and drivers change the game. Match voltage and current, plus give yourself a bit of a margin. Always check the SCCR or the short circuit current rating and environmental ratings, NEMA and IP. And don't forget to count your poles and throws. Now you've got the roadmap to pick the right disconnect every time. No guesswork, no regrets. Thanks for watching. And remember, the right disconnect switch doesn't just complete a circuit, it protects everything behind it. For a full line of disconnect switches and hundreds of thousands of other industrial automation products, please go to our website. That's rspsupply.com, the internet's top source for industrial hardware.